Hey guys, I'm back with another video, and this one is going to be centered around exponential types of functions that you see on the ACT. Some of them are really neat, and it'll be really useful for you, I think. With that being said, a lot of these problems are taken from wide spectrum exams that the ACT has released to the public. And it'll give you a good overview of how they create them. Now, please remember, we are interested in helping young adults that doesn't have any help outside of the classroom. So please like, share, and subscribe so we can reach as many young adults as possible. With that being said, let's move on to the first question. All right. So a group of cells grows in a number as described by the equation. So they give you the equation. Y is equal to 16 times 2 raised to the t power. And that tells you t represents the number of days. So t refers to days. Okay. And y represents cells. So cells. According to the formula, how many cells will be in a group at the end of 5 days? Well, just take your formula and substitute 5 into t. Now, 2 raised to the 5th power becomes 32. So 32 times 16. When you multiply those two together, you get 512. So over 5 days, you're going to see 512 cells. Answer choice D. Next question. They give you an expression and they want to know what it's equivalent to. So they're asking you to really simplify it. And in simplifying it, we're just going to get rid of the parentheses. So let's get over here and rewrite this. Negative 8x cubed times 7x to the 6th minus 3x to the 5th. Now, multiply your negative 8x cubed through to both terms. So negative 8 times 7 is going to be a negative 56. And then your x cubed times your x to the 6th becomes x to the 9th. Remember, we're multiplying, so we add the exponentials. Now, negative 8 times negative 3, a negative times a negative is a positive, so that's going to be 24x to the 8th. Now, look that up over here for our answer choices and look for the plus sign. Negative 56x to the 9th plus 24x to the 8th. That's answer choice A. Be careful because right below it, answer choice B has a negative sign in front of the 24. A lot of people are going to choose B as in boy, and they're going to be wrong. Be careful with your signs. Now, for any non-zero value of y, y to the negative 5 raised to the 3rd power is what? All right. So we have y to the negative 5th raised to the 3rd power. Let's go ahead and take care of our exponents. So that's going to give us a negative 5 times 3 is a negative 15. Now, we have the negative sign to deal with. Now, this is like being written over 1. We want to move our exponents around, so we're going to move them to the denominator. And that's going to be rewritten as 1 over y to the 15th. And that's going to be answer choice F. Now notice answer choice B has y to the 15th. So be very careful. Next question. Okay, so we got 10 raised to this equation, which they're making that equal to 1. Well, anytime you see 1, begin to think, how can I rewrite 1 with the same base of what's on the other side of the equal sign when we're working with exponentials? So here's what we have. We have 10 raised to the 2x minus 1 over x, it's set equal to 1. Now, how can I rewrite 1 legally, mathematically legally? So I can rewrite it by saying 10 to the 0 power, because 10 to the 0 power is 1. But notice it puts 1 in the base of 10, which matches the other side. And when we do that, we are then permitted by the rules of mathematics to pull the exponents out and make an equation out of them. So we get 2x minus 1 over x is equal to 0. Now we can keep simplifying. Multiply both sides by x, and you get 2x minus 1 is equal to 0. Solve for x now. Move the 1 to the right side. So 2x is equal to 1. X is going to be equal to 1 over 2, which is 1/2. And that's answer choice C. The key here is recognizing this piece, rewriting 1 as 10 to the 0 power. Keep that in mind. Oh, okay, so we got an interesting problem here. We have whenever j and k are positive numbers such that the square root of 3 raised to the j power is equal to 27 raised to the k power, what's the value when j is divided by k? Well, we got to work with this to get it in the form of jk. So we start off with the square root of 3 raised to the j power, and that's equal to 27 raised to the k power. Now, notice I've got a radical on the right. So what I want to do is change my radical to an exponential. And remember, when you do that, inside the radical, it's like saying 3 raised to the first power, and there's a 2 on the outside of the radical to denote square root, right? So that changes this to 3 raised to the 1/2 power. Now raise it to the j power. Now that's equal to 27 raised to the k power. Now let's go ahead and deal with our exponents on the left side. So this is going to be 3 raised to j over 2 is equal to 27 raised to the k power. Now, be very savvy here. Notice that there's multiple 3s with the 27. So we can write 27, we can rewrite 27 as 3 cubed. And that gets our bases into the same base on both sides. That permits us to use the exponents as an equation. So I'm going to rewrite 27 as 3 cubed. Raise it to the k power. Just leave this over here as it is for now. Now go ahead and multiply 3 times k, and we get 3 raised to the 3 times k power. And that's equal to 3. The other side is j over 2. Okay, key point. We got both sides in base of 3, so we can pull out our exponents. J over 2 is equal to 3 times k. Let's solve this for j, because remember, we're trying to figure out what j over k is, right? That's what we're looking for. Solve it for j. We're going to multiply by 2 on both sides. So j becomes equal to 3 times 2, or 6k. Now we know j is 6k. So let's substitute j into what we're looking for. And when we do, that becomes 6k over k. Now check this out. The k's cancel, and it leaves 6. And that's answer choice K, ironically. There's a lot here. And if you really understand this problem, you have a really good grasp on your mechanics of your math, and you probably be pretty successful on the math test of the ACT. Let's move on to the last problem. So finally, which of the following equations represent C in terms of A? So we want to solve for C in terms of A. For all real numbers A, B, and C, such that A cubed is equal to B and B squared is equal to C. So what we have is A cubed is equal to B and B squared is equal to C. The commonality between these things is the B's, right? So B is A cubed. So let's substitute A cubed into B squared. And we'll have A cubed squared is equal to C. So 3 raised to the second power is just A to the sixth is equal to C. And therefore, we end up finding out that it is answer choice F. Now, these have been some pretty good problems to work through with you, and I think they're very valuable to you. Most people struggle with these that I have worked with over many years. They've been the common problems that people have struggled with. So please take them to heart. I hope it helps you. And I know the ACT and SAT is coming up here shortly. So for all of you that are really studying, I hope you're studying diligently and wisely. And don't quit. Don't quit until test day. And once that test is taken, walk out of there, forget it. And just remember, you can always take it again. All right, guys, good luck to you.